Good evening, guys, and the ones that will listen to this. Basically, just going to end off study unit 6 with that one question still left from last week, and then going to focus on study unit 7. Okay, so let's look at study unit 6, that last question, and basically, again, you will get the tables in a booklet, but else you need to basically use the tables that are in your study guide, and again open book, so you will be able to use the ones that you have. So basically, the last one of study unit 6 that we didn't complete last week, let's just run through the information that they do give us, and then see what we are missing and what we need to do. So the question in the end is, what is the probability of weights of a large group of high school students that it will be more than 63 kilograms? So in the end, we need to work out the probability, but at the moment, we don't know for what Z value yet. And they don't give us the Z value, so we will need to work out the Z value. So let's read what's more in this question. So the distribution of weight of a large group of high school students is normally distributed with a mean. So firstly, it is normally distributed with a mean of 55, standard deviation of 5, and then what is the probability students will be more than 63? So basically, Z, what's the probability that it will be more than the 63? So 63 minus 55 divided by the standard deviation, which is 5. So what's the probability that Z is bigger than 63 minus 55 is 8. 8 divided by 5 is 1.6. So what is the probability that Z is bigger than 1.6? And then again, I normally draw the normal diagram. 1.6 in the middle, 0. So we know to that side of 0 it's 0.5. So this area we are looking for, so it will be an answer that is less than 0.5. So not that option, not that option. So we sit with so we basically have these 3 options that we can pick out of. So bigger than 1.6. So let's look at 1.6, 1.60. So we have 0.9452. So if we work with that and didn't realize that we need to get the smaller value, we would have selected that, which would have been wrong. So basically, just to look at that again, the area that they gave us for the 0.9452 is this area. We want to get that area. So we need to say 1 minus 0.9452. that is equal to 0,0548, which is option 4. Again, just if you quickly look at the answer, and maybe you'll answer option 2. So just again, be very clear on the sequence of a number, that you don't make a mistake like that. Okay, so this one, again, from study unit 6, was basically, here they ask us to work out the Z so that we can get the probability of a number bigger than. So as in previous questions in study unit 6, you can also get that they give you the Z, and you just need to go and look for the probability. They give you 2Z, so it can be a few things that they can ask you in study unit 6. Okay, so let's go into study unit 7. Yes, question.
Sean, quickly,
Yes.
for this problem, if you're looking on the right-hand side for the smaller value, can you go to the positive tables or is it the negative tables? I'm just trying to see without the 1 minus.
Okay, so if you wanted that small area, you could have gone directly to the negative table, and you could have looked at negative 1.6, and you would have gotten that answer.
Okay.
So every time that you're looking for the small probability, you can always look at the negative table.
Tables.
Yeah.
Okay.
So if you, and let's quickly just include a new slide. So if I want that small area or that small area, and you want to get a probability, you can use the negative table. If you need this area, or the other way around as well, if you need this area, you use the positive table. Then you don't need to say 1 minus or anything like that. Because again, sometimes you have that small area, but you actually need the bigger area. And then you would have gone to the negative table, get that, and then you must again say 1 minus. So if that was minus 1.75, and you needed to get what is the probability that it is bigger than minus 1.75, it would have been the same answer as if it was smaller than positive 1.75. Okay, so again, either or. So when you're looking for only the small area, use the negative table. If you're looking for the bigger area, doesn't mind if it's a negative or positive. If you're looking for a bigger area, use the positive table. Okay.
Thank you.
Cool. Okay, let's go into study unit 7. And with study unit 7, basically what we are now doing extra is study unit 6 was looking at your normal distribution. You would see that we normally talk within there. It would have been talking about the population. Now we move into sampling. So sampling of a normal distribution with a mean and proportion. So the only thing that nearly changes in the way we approach it, if we do sampling distribution of the mean, is that there is a extra component coming in, and that's basically just looking at how big the sample is. So remember in study unit 6, we would have said your Z is equal to the X minus the mean divided by the standard deviation. So the only thing that now comes into play is that we say, okay, so if we look at the mean, the only difference is now we're talking about a sample. So it's still X minus the mean, but the only difference now comes in that the standard deviation is not standard deviation anymore in totality. It becomes the standard error because we need to account for the sample. So the sample size basically plays a role in it, and it's not supposed to be a huge impact on your answers. That's why sometimes you will get one answer that is 0.945 and the other one is 0.935. And it's just because that small difference is because of the sample that you have incorporated or not. So the only difference between study unit 6 and study unit 7 is that instead of looking at the population, we're now looking at the sample. So the other one that is being introduced in this study unit is when we look at proportions. So if we look at proportions, we basically have another formula that we are going to work with. So it is nearly the same to say the X minus the mean. So here we will have a population proportion and the sample proportion that we work with. And then we will also have a standard error of proportion that we work with. So basically these two are the formulas that we will work with in this study unit. What is also, as you will see in your assessments as well, a thing that they ask a lot is for you to actually work out what is the standard error. So that is nearly the one thing that you just need to look out for in both of the standard error for the mean and the standard error for proportion. But again, this formula is on your formula page. You don't need to go and study it and learn it off by heart or anything like that. It is there for you. Again, I'll think I have shared some of the formula pages, but I'll just share again for everybody that's new on all the groups as well. I'll just do that as well. So what we will do in the next few questions is also with the sample proportion and sample mean, you can't really, it's not like binomial and Poisson that you need to be very certain of which one you work with, because they will say it out straight. There's no hiding in these questions because they need to tell you. So they will tell you, like in this question, normal population with mean. Let's quickly run through all of them. Normally distribution, population with a mean. Okay, this is more theory question. Random variable normally distributed with a population mean. Binomial experiment. So again, and I think this is nearly the link as well, with because it's proportion, it is something is happening or something is not happening, it is actually a binomial experiment. So it is actually a binomial probability, but it is taking the binomial probability a step further. But here they will again say proportion. If you look at the next one, population proportion. The next one, simple random draw process, proportion. So they, with this one, and again, proportion. So with study unit 7, it is definitely not the case to catch you out with anything. What they normally can catch you out with is asking for the standard deviation, or sorry, the standard error, but they also give one of the Z scores as one of the answers, so that we want nearly read past the standard error question and automatically want to work out the Z score, automatically want to work out the probability, because that is nearly what we are trained to do in this study unit. So when you also do your assignments, just be very careful what they actually want you to work out. Is it the standard error that they want you to work out? Is it the Z value that they want you to work out, or is it the probability that they want you to work out? So let's look at this question then, and let's see if we can solve it. So a sample of 16. So when I look at these questions, I know this is going to be my formula, so I just always write it out so that I can work with that. So n is going to be 16 observations is drawn from a normal population with a mean of 1,000. And a standard deviation of 200. And we know it is divided by square root of 16. Use the standard normal Z tables to calculate the probability that X is bigger than 1050. Okay, and then bigger than that. Okay, so even before I nearly work out anything else out, I know the top is going to be 50. That can't be negative. So my answer, if that is 0, my Z is going to lie somewhere in this area. Okay, so my Z is going to lie somewhere there, even though I don't know what it is yet. It is going to be somewhere there, and I need to work out the Z bigger than that. So I know already that my Z is going to be smaller than 0.5. So with being smaller than 0.5, it's not that one, it's not that one, it's not that one. So again, nearly already eliminating 3 of the options that they've given you without nearly working out the answer yet. Okay, so now let's go further. So 200 divided by 4 is 50. So we are looking for the Z that is bigger than 1. Okay, so let's see if I can just wait, undo. Let's just copy it. Okay, so I'm looking for Z bigger than 1. let's use a different color. Okay, Z bigger than 1. So Z bigger than 1, the 0.8413 is there. But obviously, that one is wrong because we're looking for the smaller. So again, we could have gone to the negative table and look at -1. But let's just make this for completeness sake. We go to the positive table, we need to say still 1 minus, and we will get the answer of 0.1587. But if we used the negative table and we looked at what is the probability where Z is equal to -1, we would have gotten the minor or the 0.1587 as well. Okay, so, but again, it's nearly, I wanted to show when you've drawn this already, you could nearly eliminate a lot of the options already without even calculating any of the answers yet. Is that a bit clearer as we go through this, because I think study unit 6 and 7 is very much related nearly and very similar. It's just one or two things that is extra. Okay, I just want to add a few of these ones in. Okay, so the next question. A normally distributed population has a mean of 40, standard deviation of 12, sample size of 100. Okay, but what do we need to get? We need to get the standard error. Okay, so we just need to get that small piece that is under the equation. So we need to get the standard error, which is equal to the standard deviation divided by the sample square root. So normally distributed mean, standard deviation is 12, standard error of a sample mean if a sample size is 100. Okay, so then it is 12 divided by 10. 12 divided by 10 is equal to 1.2. Okay, and we've got option 3. So the things to look out for in a question about standard error as well is that sometimes just look if I give you standard deviation or if I give you variance. I think this is one place where they might give you different information, but otherwise there's nothing else nearly that on the standard error that can catch you out. The other thing nearly to also be cognizant of is that you don't, because we work with the x minus the mean over the standard error, that we don't say 1 divided by the standard error to get your answer. So just, I don't think you guys will, but just because then one of the other options would have been. So just as nearly, they only want the bottom part. So they don't want to see it as a whole. They only want to see the bottom part. So that is just maybe if one is rushed for time and you write down the formula. Also, I think when you worked this out, no, they don't give you enough information, luckily, to work out the Z. So you couldn't have worked out the Z. But what they can have asked you is they've given you the mean. So what they could add it to this was the X value. So just be careful that they don't add a X value and you work out the standard, the Z value. Okay, so standard error of a sample mean question. Let's look at what's in the next set of questions. So this one is looking at a few things. So by asking you nearly to look at the information that they give you, they ask you if it is, which one do you think is incorrect. So let's look at the things that they do ask you. So which of the following statements is incorrect? The sample distribution of a mean will have a mean as the original population from which the samples were drawn. True or false? What do you guys think? I think there was nearly a question like this on the chat in the week as well. So when we work with study unit 6 and 7, we can assume that your sampling distribution of a mean and your original population mean will be the same. Okay, so that is correct. The standard deviation of a sampling distribution of a mean is also called the standard error. That basically we just went through, so perfect, correct. When the population mean is 160, the population standard deviation is 25, your N is 64, the standard error is. So they're asking you to work out, so here they ask you that you understand what the standard error is, here they ask you to work it out. So it is basically 25 divided by the square root of 64, which is 8, so 25 divided by 8. I think it will give you that answer, 3,125. Okay, so that one is also correct. So let's look at the next one. So this actually is interesting that they ask it in here because you have not done confidence interval yet at this point. So confidence interval is an estimate for which there is a specified degree of certainty that the population parameter will fall within the interval, will be in the interval. So let's just on a simple way illustrate that. So say that is your mean that you are looking at. All that the confidence interval is doing is to say that you have a certain confidence that that value will fall within that confidence interval. Okay, so later on when we get to confidence intervals, when you say you've got a 95% confidence interval, it means that you have that confidence that that mean will fall within those two numbers. So confidence interval, it is correct. Okay, so we know this one is then incorrect, but let's look at it first. So we use the t-distribution for the statistical inference of a population mean when the population standard deviation is known under the assumption that the population is normally distributed. This is interesting. Did we do this in, we also do this in study unit 8, I think. So again, it should not be part of this, but Again, it shows you that is study unit 8, I think, how they can throw a few study units together as well, specifically on this one, to ask a question as well. So once again, one will not see it as you do certain assignments, but this can happen in the exam as well, where it is basically two study units that have been thrown together. So just that you know, when the standard deviation is known, we use the Z. So we'll get to that in the next study unit, where when the standard deviation is known, we use the Z. Standard deviation is unknown, we use the T value. Now, I don't think it is in this study unit. Yeah, no, it's not in this study unit. It is only in the next one. So we'll get there in one of the next sessions. So don't worry too much about this at the moment. I'll mark this that we come back to this when we have finished study unit 8 as well, and then we can actually relook some of these questions, or this question. Okay, so I think the last one on population mean. So let's again look at the information with a population mean equal to 80. So let's look at again, so that is basically the Z. So we need to look at, that is the population mean, so we have that. Standard deviation, we have that. Probability, that is simple random sample of 25 items will have a mean that is between 79 and 85. Okay, so this is now interesting. So let me take this away first. Can always bring it back now again. So let's just do this one. So we basically are going to need to work out two numbers, two Z values, and then you need to work out what is the probability between those two Z values. So let's just get the one sorted out first. So let's work with that one. So how I normally do it is I will write it down next to one another, then at the end I can nearly see what is happening, because the other one will be then 79 minus 80, and I'm also dividing by the same number, so it can just become easier to work with. So that's for one Z. That's my one Z that I'm going to work with. That's my second Z that I'm going to work with. Yes, question. Yes, you can ask a question. Okay. Maybe, okay, let me first continue, then we can look at it again. So basically with this on the one side, and what I now see is this is going to be a positive number, this is going to be a negative number. So when I draw it on the table, I will just nearly swap it around again. Okay, so 85 minus 80 is 5. Square root of 25 is 5, so 10 divided by 5 is 2. So on this side, minus 1 divided by 2. Okay, so when we work it out, I definitely need to need to look at that as a negative. So this one will be 2.5 and this one will be minus 0.5. Okay, so then what I need to do is I need to get the probability between 0.5. Let's just, that is my 0 normally one, and that is 2.5. Okay, so I need to get that probability. So we can do this on a few ways. So we can, and maybe if somebody has one of the tables with them. So the one way we can do it to get, so basically to get this blue area is to say 1 minus the green area. So whatever the green area is, minus whatever that purple area is. Okay, so that is one way of doing it. So then it's nice to work with a negative table, because we can, on the negative table, we look at the 0.5, we get a value, we look at the negative 2.5, we get that value, and we say 1 minus the green minus the purple, and we get the answer. So that is one way of doing it. Let me just, I just want to see if, okay, so that was nearly the one way we could have done it, and then it would have, the answer would have been, so we look at 2.5. Let me just, so it would have been the 2.5 that we had in purple would have been 0.0062, and the other one was 0.5. So that would have been 0.3085. So that would have been 1 minus, it's interesting answer. I will just check if I do get that. So 1 minus the 0.3085 minus the 0.0062, and the answer should be 6853. Okay, so it is the right answer that I got. Okay, so that's the one way of doing it. The other way is to say I've got my blue area. So let me just, so that was to get my blue area. So 1 minus the green area minus the purple or pink area would have given me the blue area. The other one is to say, well, I've got my blue area that I need to get. So I get this total area. So I get the total. So let me rather do it on the, but we don't get confused between all the colors. That was 2.5. That was minus 0.5. Okay, so we use this table, we get that whole blue area, and that whole blue area is 2.5, so it is 0.9938. And all that we do is we subtract the smaller area, the green area, because that will give us then the area in here that we are looking for. So then we just subtract the 0.3085, and then we are supposed to get to the same number as well, 0.6853. So there's a few ways that we can do it by using or only the negative table like we would have done here, or using the positive table and the negative table. And again, there's not just one way of doing it. So whichever way is, again, easiest for you to do, use that. Again, there's no, they're not going to mark you on the method that you're going to use. They won't even know what method you used. So the one that is easiest for you, use that. If you wanted to say, okay, it's easier for me to use the negative, I know then what those small two areas is. I know everything below the normal curve must be equal to 1. So 1 minus those two small areas, I get my answer. If you wanted to say, well, I'm very happy in using this table and the negative table, so I know that this area I get from the positive table. I get that value of z that is equal to 2.5, which is the 0.9938. Also, I know that the smaller area I can get from my negative table. I go to the negative table, I get the 0.3085. To get to that chunk of probability in the middle of it, I need to subtract the two numbers, and I get my final answer. Again, both methods, you see both methods does give you the same answer. Use which one you feel most comfortable in getting to a final answer. Okay, questions on this before we go into the sample proportions. So the sample mean, basically the only difference between study unit 7 and study unit 6 is that we introduce the sample size. Otherwise, the formula is very, very similar. Okay, let's go into the next set of questions around sample proportion. Okay, so the first one on sample proportion. In a binomial experiment with a sample size of n equal to 300 and the sample proportion of that, the standard error for proportion. Okay, so we need to get to the standard error. So the standard error is basically okay, so what is interesting now, so is that we need to work out standard error of P. So that's a standard error of P, very similar. Okay. So P is 0.5. 1 minus 0.5 is also 0.5 divided by N, which is 300. So 0.5 times 0.5 divided by the 300, and then we need to square root. So that is also, sometimes we stop at that position and not square root. So remember, very important to square root it as well. And I won't be surprised if one of the answers is yes. So before we square root it, the answer is 0.00008. So if we didn't square root, there is an option for you. So then we take the square root of that, and that is equal to 0.02 0.288. So y is mine different. Did I miss it somewhere? 0.5 times 0.5. Point 0.5 times 0.5 divided by 300 gives me 0.008333, and if I square root that, it gives me 0.02887. So it will be interesting if I say 0.0008, even if I square root that, it does give me that. So this is a bit, not, so if you basically take the 0.0008 and you square root that, so on your calculator, actually you needed to retype that, then you only get this one. So this will not happen in the exam, because you want to get that answer, because that is the 0.0008, how you worked it out, and the square root of that. So again, in the exam, this will not happen, but that is the answer. It would be, or that would be the answer, not that one. And if it is that, there won't be anyone close to that. But option 1 is your answer, but it should be 0.0288 and not 0.0283. Okay. Okay, so basically working out the sample proportion, and again, remember, sample proportion is written with a P, the population is written with that. So if we go back to our previous slides, the population is denoted by that, the proportion is denoted by the P. Okay, let's go into the next question. So consider a population proportion. Calculate the standard error of a proportion for n. So again, here they ask us the sample proportion. They can also ask you the population proportion. So the standard error of of a population proportion, you work out exactly how you would have done for the standard error of a sample. So very similar, and I've written that on the previous page as well, the formula. So nothing new, follow the same process, 0.68 times 1 minus 0.68, which is 0.32, and that divided by the square root of, nope. Again, easy to make the mistake with the previous work that we've done. The square root of that whole equation. So 0.68 times 0.32 divided by 20. So we need to get the square root of 0.0109. Okay, so again, there is that option. So if you didn't square root it, you would have gotten one of the options. So if we square root it, we get 0.1043, which is option 1. Okay, so again, very important for all the standard error questions, the thing that is beneath or under the square root will always be one of the answers. So just remember that, always to look out for that. We need to remember to square root to get to the final answer. Okay, so let's see if there's what other question I have in here. So simple random sample, n is 300, is drawn from a binomial process. We know what the proportion is. The test statistic for the proportion of success, P is equal to 0.35 is. Okay, so how do we calculate this? Okay, so now I just need to remember the formula. Again, you don't need to remember it. It is in your book. It is in the tables, in the formula sheet that will also be provided to you. Okay. So P is 0.35. So let's see, 0.4. 1 minus 0.4 is going to be 0.6 divided by n is 300. Okay. Before we go on with the calculation, what do you guys see with what I've got here? Anything that you pick up? Anything that you pick up in this part? Okay, it's going to be negative. So 0.35 minus 0.4, 0.05. So without even calculating the rest, we know the answer is going to be negative. Look at your answers. only one that's negative is option 4. Okay, so we didn't even, for this question, needed to go any further because we knew the answer is going to be negative. We only have one solution that is negative, so we can take option 4. But let's just complete it so that if it wasn't like that we still knew what to do. So 0.4 times 0.6 is 0.24. So 0.24 divided by 300 and the square root of that is 0.0008. So let me just, so we've got minus 0.05 divided by 0.0008. Okay, and that answer then now getting wrong answer, so let me quickly check if everything was done correct. 0.4 times 0.6 is 0.25. The sample is 300. Oh, now I make the mistake. That is square root. I didn't square root it. Okay, so my answer is 1,76. See, so again, that final, because I get 767. Oh well, rounded off, it is correct. Minus 1,767. So it is correct if I work it out like that. So again, nearly a tip that if you look at that first component, it is going to be negative. So then the only answer in these options is negative, is option 4. The other thing that I would have looked at my answers is to see, oh yeah, I've got a negative. Yeah, I've got the same one that is the positive, which let's just make sure this is saving and okay. So I would have looked at this as well from the start and say positive number, negative number, which are exactly the same. So I would have thought, okay, one of them would probably have been the correct one. And then if I go through it, I also see the negative. So that also gives me the indication which one I would have gone to. Okay, but this one, basically, you use the same principle as you would have done with the mean. So even when, and let's just look at it, if I ask you to work out the probability that Z is smaller than that number, so let's just take it a step further. If I said work out that probability, so then we would have said, okay, where's the Z? Minus 1,767. 767, just rounded off, that we can use with tables, is minus 1,77. Smaller than that, we want to get that area. That area we can basically get from the negative table. So we can have gotten that from a negative table, or we could have gone to the positive table and set 1 minus the value that's in the positive table. So again, nearly from the same question, they could have taken it a step further to ask you to work out the probability as well. But for the proportion, very similar to the standard mean, is basically you work out that Z value. So, and that Z value for the proportion, as the same with the mean, you use it as you know it. So you would go to the Z table and get your probability. So it doesn't matter when we look at proportion or mean, we know that we will go to the Z table, and the Z table we use as we normally would have done for the mean as well. Okay, questions on this one before we go into the last question, nearly, or bit better understanding at the moment on study unit 7. Okay, so let's look at the last one, and then we can also look at some questions. Okay. In a random sample of 85 people from a population, X is the number of left-handed people. In the population, a proportion P equal to 0.2 of the people are left-handed. What is the standard error for proportion? Okay, so again, standard error, when we do standard error, and it's standard error of a proportion, we work with that formula. We know what the proportion is, it's 0.2. We know what the 1 minus P is, and we know what the sample is. Okay, so 0.2 times 0.8 is 0.16, divided by 85 is 0.001882. So if we have rounded it off, that would have been your answer. But we haven't square rooted it yet, so when we square root it, we get to 0, wait, where is, we get to 0,0434, which is option 2. Okay, interesting question. What would you have done if I ask you right-handed? What would you have done if I asked you, they tell you that X is the number of left-handed people in the population, it is a proportion of 0.2. So what if I asked you, so what is the standard error for proportion for left or for right-handed? So if I ask you for right-handed, what would you have said? And something interesting comes out that I think just for you guys to know. So if that is left-handed, how many are right-handed? Okay, so if 0.2 of the population is left-handed, the rest are all right-handed. So if 0.2 is left-handed, 0.8 will be right-handed. What is very interesting when we work with a proportion, it's actually already there. So even if we've now said the new proportion is 0.8, we would have multiplied it by 1 minus, which is the 0.2. So basically, what this calculation does is to say, you know the one proportion, and you multiply it by the other proportion. So here you have the left-handed, and you multiply it by the right-handed. So basically, if we look at the previous questions as well, so whatever this was, that could have been the left-handed, then that part would be the right-handed. So, and that is why it's very seldom, so you can even make the mistake if they name it something different, because here you would in any case correct your answer. So just in this instance, because it is again looking at binomial distributions, we know from what was his study unit 4 or 5 that binomial an event occurs or not occurs. So again, always if the one occurs, the other one does not. So if it's left-handed, the other is right-handed, and just the opposite happens. Okay, so this is just to show you nearly what is happening within that formula. So it is the probability that they give you minus nearly the opposite of that probability. Okay, so that is study unit 6 that we have completed. Just the last question from previous week, and study unit 7. So just again, recap of study unit 7 is basically taking that sample mean, or that Z that we've calculated in study unit 6, just a step further, that we introduce the sample to it, and then we add proportion to it as well. Study unit 8, we will nearly expand on this to say confidence intervals around the mean, and we will look at the confidence intervals around the proportions as well. But that is in study unit 8 that we will look at this. So basically, study unit 7. The next step is to go into study unit 8, which we will just introduce confidence interval on basically these two concepts of the mean and the proportions. Okay, any question, guys, that you want to ask about study unit 7? Is it a bit clearer? I don't know if any of you have started to attempt assignment 3 yet, but hopefully this is in line with what you will get in study unit 3 on, yeah, or from assessment 3, sorry. Have any of you started to look at that or not yet really? Okay, I assume that is a not yet. Okay, so good luck with assignment 3. And I will post the link to this recording onto the chat again. Okay, thanks guys. Have a good evening on your side. And that is until our next session. Cheers, everyone.